Hey, can you believe it? Last question. And like I've said before, this would, in fact, yes, this is a momentous moment. This is technically the last one I think I'm going to do for the Nat Fives. So if you've watched all the way through, hopefully you've seen me get better rather than worse. But yeah, I've started at 19 and worked my way through to this. So what a journey. There we go. Hopefully it's been useful to you. I've certainly enjoyed doing them. It's interesting for me to practice. Hopefully you get something out of it. And again, good luck if you've got any exams coming up. But yeah, here we go. Last question of these. Oh, wow, can't believe it. What am I going to do with my time now? Crazy. Okay. Question 14. A rectangular picture measuring 9 by 13 is placed on a rectangular piece of card. The area of the card is 270. Okay, so let's have a think. So 9 by 13, this bit here, rectangle, this is the picture. Okay, and then the card is on the outside of it. Okay, yeah, so there's the picture, there's the card. All right. So the area of the card is 270. So the area of that is 270. Okay. And this is X. Okay. Yep, so fine. Write down an expression for the length of the card in terms of X. For the length of the card. Let me have a think about this. Do they mean, oh, the length as in, yeah, so this length here in terms of X. Okay. I thought they meant like an overall perimeter. So I was like, oh, yes, sorry, there's the length there. So they want to know this in terms of X. All right, well, looks to me like it's 13 for this part and then X and X. So I'd be thinking the length is equal to 13 plus 2X. Oops, I'm saying 8. Okay, seems fair, doesn't it? So yep, that length there. Okay, and then hence show that this equation holds true. Okay, well, it must be to do with multiplying. We've got a squared, okay? So I would imagine it's to do with multiplying uh, lengths and widths together. Let me have a little think. Let's see. Yes, so we know that's the length. Now, what they really should have said to make it a wee bit easier, I think, would be to have said, well, what's the breadth? Yeah. So the breadth is going to be 9 plus 2x. Yeah. So I think they should have maybe asked for the two of them just to kind of get you thinking, but okay. And then hence show this. So it looks as if they want us to multiply the length and the breadth together, and that will equal the area of 270 that they've given us. Okay, so if we say 13 plus 2x multiplied by 9 plus 2x, the length times the breadth, that is going to be equal to 270. Okay, that's what I'm thinking. Okay, so that's just length times breadth equals area. Okay, so let's do that. 2x and 13. I'm just going to write it out the way I usually do with my x's at the top and then numbers last. Just do a little box as usual. So 4x squared, right, it's looking good. 26x, 18x, 9 times 13. Well, if you're not good like me, just do this. 9 3s are 27, 9 1s are 9, 11, okay, 117. And then let's put our terms together. So this is going to give us 4x squared plus 26 with 36, 42, that sounded right, 44. Sorry, 44, yep, plus 44x. I'm running out of space. 44 plus 117 is equal to 270. So if we want to bring the 270 over, we're going to do 117 minus 270. So that is going to give us minus 153. 4x squared plus 44x minus 153 equals 0. Good stuff. So I think looking at this, I mean, it took me a wee while for my brain to kind of get going there. I was thinking, what are they going for? But yeah, I think if they'd said work out the length, work out the breadth, and then show this, it might have got me thinking. But at first I was kind of a bit confused how to work out breadth. But then I thought, well, I've got 9 here, so I'm just doing the exact same thing. So maybe a little bit tiny bit harsh, especially towards the end of the paper. We were fried, and right now it's 2 a.m. But got nothing else to do. So yeah. I'm trying to think if there was an obvious way to think of that. I suppose seeing the squares, it made me think, well, I'm going to be multiplying x's together. They want a length, so it'll be something to do with an area, and they give you an area. So the clues were there. Hope you're probably faster than me even getting it, but yeah, in essence, that's a very simple question. Coming up with an equation, so 13 plus x, fine, and then multiplying two brackets together, collecting your like terms. Pretty actually very straightforward once you get going, once you realise what it's asking. Okay, cool. Question B. Calculate x, the width of the border, give your answer to one decimal place. Okay, now if we go back to our equations at the very front, let's see if I can remember what we've done. Okay, so we had standard deviation in the non-calc, I think. We didn't do a volume of a pyramid or a cone, but we did do volume of a sphere. We have done area of a triangle at least once, possibly twice. We've used the cosine rule, we've used the sine rule, we've not used this yet, okay, the quadratic formula. Okay, minus b plus or minus the square root of b squared minus 4ac over 2a. We've not used that yet. I'm just going to write that up here, minus b plus or minus the square root b squared minus 4ac over 2a. Now, you might be thinking, why is he written that? Why is he instantly gone for that? Well, calculate x. Okay, so we've got a quadratic here, so 4x squared plus 44x is 4x squared plus 44x minus 153. Yeah. If we're solving for x, we're factorising. Now, I don't know about you guys, but I cannot instantly factorise that. It doesn't jump out as me as being something that we can use our trinomial for. I've discussed the 5 methods earlier on. And the clue's actually here. See when it says give your answer to one decimal place, right? That's basically saying we're going to be using this formula because you don't factorize things to one decimal place, you factorize it to a whole number. Okay, so yeah, when I saw this, I was thinking, right, I'm solving a quadratic to one decimal place. It's got to be this equation. Okay, if you've not used this equation in your paper, you probably missed something. Okay, I think it's come up in every single paper. Okay, so it's a favourite. So when I do this, what I like to do is work out the discriminant first. Okay, so that's your b squared minus 4ac. Okay, I always like to do that first. So maybe just over here, I'm going to write down what a, b, and c are. So a, b, c, that's the coefficient of this, this, and this. It's all in a nice order. So really, so far, now we know to use it, we shouldn't be thinking, oh, this is dead tricky. Very straightforward. Okay. Now this is called a discriminant. Okay, just going to box this off to keep it tidy. Right? In fact, just to be pedantic, okay. So the discriminant b squared minus 4ac. Now this is good. This comes up sometimes as well. So when we work out the discriminant, we're working out this number in here. Okay. Now if you look at that as a square root sign above it, if we get 0, okay, this equation goes down to minus b plus or minus 0 divided by 2a. So basically it comes down to minus b divided by 2a, i.e. you get one number. Okay, and that's because when the discriminant is equal to 0, you have got one root. Okay, the graph, whichever it is, touches the x-axis once. Okay, so that's what your graph would look like. Okay, that'd be for negative x squared, positive x squared. All right. If your discriminant was less than 0, it was negative, you can't do negative square root. Okay, not with real numbers anyway. So what you've got is a graph that's doing something like this. Okay, so you've got no roots because you're not crossing the x-axis. Okay, that's what the roots are. It's where the graph crosses the x-axis. Okay, so when y is equal to 0, so it's when it crosses the x-axis. Okay, so because we know this is equal to 0, so it's we're looking for y is equal to 0, so it's going to be where it crosses the x-axis. All right. Now when it's bigger than 1, we're going to get two numbers. Okay, because we're going to have plus or minus, plus the number minus the number, and that's something like this, where it crosses the x-axis twice. Okay. And that's our two roots, that's our two answers. Okay. So that's why I always do this one first, because some of the questions only call for the discriminant. They just want you to work that out and then state the nature. Say this has got one real root, this has got no real roots, this has got two real roots. Okay, so I just like to do that first. So first of all, I'm going to do 44 squared minus 4 times 4 times minus 153. Okay, so let's do that on the calculator. So that should give us a big number anyway. Should really know what 44 squared. 44 times 4 is 1936 for 44 squared. Lewis Hamilton's Formula 1 number 44. 4 times 4 times minus 153. So all that I'm getting 4384. Okay, 4384. So that's my discriminant. Okay, so I think that's, oh, it's a shame that doesn't quite just tie in, but okay. That's my discriminant. I think that's a really good one to work out. So now I'm going to substitute in the rest of the equation. Okay, so I'm going to say minus b, which is minus 44, plus or minus square root of 4384, and I can tell there's going to be two roots because that's positive, it's bigger than 0. Divided by, I'm just going to write 2 times 4, just to fully have it all substituted in. That's the way I like to do it. Okay, I know that's 8, but I'm just going to write that. Okay, so now I'm going to go in two directions. I'm going to say, well, I've got minus 44 plus the square root of 4384 divided by 4, and I've got minus 44 minus the square root of 4384 divided by 8. So that should give me, let's have a look, so minus 44 plus the square root of 4384. I'm just going to put them in a bracket because, like I've said, I'm paranoid about brackets. So I've done, effectively on my calculator, what I've done is this. Okay, just kept that in a bracket because I don't want it doing this divided by 4 on its own. Okay, so that's just the way I roll. That's just me being paranoid. So I'm going to get from that 5.55, and for the other one, I've just changed the sign to negative. That's going to give me minus 27.55 as well. Okay. Oh, it's not divided by 4. What am I doing? Sorry, what am I doing? It's divided by 8. I've done 1 divided by 4 and 1 divided by 8. See that? So let me just try that again. So this is minus 13.78. See, it is easy to make mistakes, but honestly, if you just keep looking at what you're doing and just having a think, you will be absolutely fine. Everyone makes a little boo-boo, and obviously go back and check it as well. Okay, it's totally fine. Don't stress about it. I think we're in centimeters as well. Okay, so yeah, I'm thinking that's pretty good. I'm finished the question, but have I? Let's just quickly read it. Give your answers correct to 1 decimal place, first of all. So the 1 decimal place, 2.8 centimeters and minus 13.8 centimeters. Now I've almost finished, okay, because I've reread the question, but have I really given the width of the paper? Have I really answered the question? No, not really, because this is an invalid result, isn't it? Kind of a negative length, okay? So you get rid of the irrelevant one, and then write the final one. Now I've just scored that out. Actually, to be fair, right, in the exam, don't do that, okay? Maybe don't score it out. I would then say length is equal to 2.8 centimeters as minus 13.8 is not applicable, something like that, just highlight that. That way your marker knows you understand what you've done. Okay, you solve for x, and this is irrelevant. Maybe don't actually physically score it out, actually maybe do a separate line. Okay, so yeah, solving for x using the quadratic formula, 1 decimal place. The 1 decimal place is the giveaway that you're going to use the quadratic formula. Okay, working out discriminant, I talked through some of that. That's the way I like to roll. You'll have 2 answers. One of them will probably not apply. I'm running out of time. If you want to double check that, you could substitute it back into one of these and work out your width and your length. And I'm sure if you want to apply them together, you'll get 270. So you could actually check that as well. So you could put it into these questions. Look, I hope that was really good. I enjoyed doing it. Thanks very much for watching. Good luck in your exams. Please feel free to leave a comment, subscribe. Thanks very much.